So thanks everybody. Thanks for being here. I really appreciate it. I have a wonderful job, and at the California Academy of Sciences. And probably the thing I like best about it is giving public talks. And then to give a public talk in the place that is just absolutely really special to me, the Channel Islands, and all of you are here because these are special places to you, is just really fantastic. So thanks for coming and being here, and for the invitation, for Laura and Kristen and in the park for being here. The work we do on the Channel Islands, I just want to sort of say, I work with a lot of people from a number of different universities and institutions, and I'm going to talk about some of that work tonight and sort of meld it all together. We also work with Shumash partners to make this all work, Channel Islands National Park and the Sanctuary and TNC. So all of this stuff that I'm going to talk to you about is a Herculean effort by a lot of different people and a lot of different communities and interests. So I wanted to acknowledge them and thank them for all their contributions as well. So today I want to take you through about why I think the Channel Islands are central in helping us figure out when and how the first Americans arrived. And I'm going to take you on this I'm going to start off on this story about how us archaeologists told you all the wrong story for decades, all right? And we're trying to figure out the new one. So this idea of the Human Odyssey and when and how humans migrated and occupied different continents and landscapes around the globe is perhaps one of the biggest questions that anthropologists and archaeologists confront. This migration over 100,000 years ago, 200,000 years ago, migrations out of Africa and around the globe. And certainly for us here in the Americas, the timing and route of this migration into the New World, into North and South America, has been a point of fascination. And for the first scholars to look at this, the consensus was, and this certainly wasn't everyone, but the consensus was that the New World had a very short chronology, and claims for deep antiquity of humans in the New World were often met with skepticism. And until the 1920s, most scholars believed that peoples reached Americas sometime only 4,000 years ago. And this has a lot to do with the politics of European colonization of the New World. It's much easier to dispossess people of their land if you believe they haven't been here very long, right? So this was steeped in politics, it was steeped in racism, but it was also sort of a conception of, well, that Native Americans in the New World didn't have the technologies, the agriculture that was seen in the Old World. That turned out to be wrong, right, in many ways. In some ways, there were different technologies and different adaptations, but this was sort of what the leading scholars, what most anthropologists, what most archaeologists believed for a long time. That fundamentally changed with the discovery of one site. This happened in 1924 with the discovery, and this is a reconstructed photo of it with a fluted, clearly human-made projectile point embedded in the ribs of an extinct bison, right? That went extinct somewhere at least 10,000 years ago. And this one instance pushed back the chronology of the peopling of the New World 6,000 years, right? And so there was this paradigm shift, and scholars and archaeologists were sort of in a race to figure out then when and how people first arrived, if it was 10,000 or more years ago. And after decades of research, a sort of coherent story started to develop, and this became known as the Clovis first paradigm of New World colonization or New World migration, right? This idea, and you've all heard this, right? If you remember this in college or high schools or grade schools, right? That it was big game hunters who walked across the Bering Land Bridge during the last glacial maximum, right? When sea levels were much lower and modern day Russia and Alaska were attached. They walked across, presumably following animals, following game. They staged in Alaska. And when things started to warm, sea levels rose, and an ice-free corridor, the Cordilleran and Laurentide ice sheets, started to separate. A route opened up into the New World. And perhaps unbeknownst to these hunter and gatherers, they followed big game, right? They followed these herds of mammoths and other Pleistocene megafauna down into the New World, right? And this story seemed to fit, right? There were a lot of sites dated to about 13,500 to 12,900 years ago, many of which had what are called Clovis points, right? These big honking projectile points. You have this flute that was taken off as sort of the last stage of its production that would help haft it onto a shaft. And these were the weapons, these were the technologies to hunt these big Ice Age animals, right? And site after site, from sea to shining sea in North America, something a little different in South America, but this made sense, right? You would see in some sites, not a lot, it turned out, extinct mammoth and bison bones in association with these Paleo-Indian Clovis points, what became known as Clovis points, and a generation of archaeologists told this story, right? Got jobs at prestigious universities, got grants and accolades in the study of this first Americans, right? And it all seemed to work. And for something on the order of 6 decades, this became the story of the first Americans and the one that you probably heard. So Clovis then became regarded as the first culture in the New World. The point of origin was presumed to be Siberia, passage into Alaska down this ice-free corridor during the last glacial maximum. They entered the New World somewhere on the order of 13,500 years ago. This was the baseline for human origins in the New World that became known as the Clovis Barrier, right? And anything older than the Clovis Barrier or earlier than the Clovis Barrier were called pre-Clovis cultures, right? And there were some rogue archaeologists out there who would suggest they found a site that's older than 13,500 years ago that was pre-Clovis, and they were met with much skepticism from their colleagues, right? And often their sites, their arguments were dismantled piece by piece, right? And this was sort of the story that developed again for 6 decades. So while this story sort of made sense in a lot of ways, there were problems, right? Any of you been to Alaska? Yeah, have you been to Alaska, right? Stood at the foot of a glacier, looked around, what does that landscape look like? Nothing, right? It's rock, it's ice melt, it's barren. It looks like this, a barren wasteland, really inhospitable. The ice-free corridor, for many folks that were telling this story, was conceived to be this fertile paradise that mammoth and Pleistocene animals were walking down, right? So while this is a bit tongue-in-cheek, the idea is it's not when the ice-free corridor opened, it's when it was habitable, right? You can't migrate down, a couple 1,000-kilometer long route without there being plants and animals to sustain sort of human migration, right? So when did that happen? And in fact, recent sort of reconstructions, paleoecological reconstructions of this ice-free corridor suggest it didn't happen until relatively late. So at a place called Charlie Lake Cave and sort of the central ice-free corridor, ecological reconstructions suggest that it wasn't until about 13,000 years ago, 12.6, that we see the kinds of plants and animals that would suggest this is a habitable, migratable landscape, if that's a word, right? I think it is. And other studies have shown a similar sort of thing, right? That bison clads north and south of the glaciers during the last glacial maximum only start to show gene flow after about 13,400 years ago, right? So relatively late, right? So if we have sites that are 13,500 years ago south of these ice sheets, how do we explain this, right? And then other data like this. So this is a really coarse data, but this is put together by someone at the University of Tennessee. But it's a distribution, and I won't get in the weeds on this, of fluted points. This just means really early points like Clovis and Clovis type points, a little later than Clovis. But the point remains, where do you see most of these points, right? Big dots means a lot, little dots means a little. Where are most of them? This is the response part of the lecture. On the East Coast, right? You see them clustered on the East Coast. Well, if you're coming down an ice-free corridor, right, and you end up in the heartland of North America, where would you expect most of these points? Perhaps in the west or in the intermontane region. Now, of course, this might be, there are a lot more people with a lot more farms, a lot more people picking up, which we should not do, archaeological projectile points and noticing these things. So this might be an artifact of archaeological visibility. Okay. If we look at the ice-free corridor, recent dating of the ice-free corridor and Clovis sites in North America and in the ice-free corridor and in Alaska, what we find are that Clovis sites in the continental US are younger, Clovis sites in the corridor are younger than Clovis sites in the continental United States. So what does that suggest? People are moving up the ice-free corridor, potentially not down the ice-free corridor. That would suggest people may have been in continental North America to move north, not moving north to south. That direction's correct there. So this was, for the most part, laid to rest in the late 1990s with the discovery of a single site, sort of akin to when that 1924 site was found. At a place called Monte Verde in Chile, and it's sort of on the southern extent of Chile. It's not on the coast. It's what we call periocoastal. It's near the coast, not quite on. It has very distinct, clearly human-made technologies and things like tent pegs and bone points and lithic stone technologies. And an archaeologist, a really good archaeologist by the name of Tom Dillahay, excavated this site. And he did something really smart, that every time a pre-Clovis site, he dated this thing to 14,500 years ago, 1,000 years older than Clovis, he did something really clever, right? Every time one of his colleagues said, well, I have a pre-Clovis site, archaeologists would descend on their site, not go to their house or go to the site, descend in the literature. That's the way we do things in academia, and sort of poke holes in their arguments. So what he did is he invited all the major Clovis first scholars at the time, got a grant, invited them all down to Monte Verde. Here they are, looking at the archaeology, and to a person, while they were there, they agreed, this is real. It's a real archaeological site, and it dates older than Clovis, and everything has changed. The story kind of changes when they all get back. One person dissented, but we won't get into that either. And just sort of give you an idea of how spectacular this site was. These are those tent pegs, and these are hides still secured to the tent pegs. This is sort of a semi-submerged site where you get really incredible preservation. This is one of the sources of radiocarbon, the radiocarbon date. So really, really difficult to argue with how precise and how excellent the archaeology is here. So again, this turned everything on its ear. So all those textbooks needed to be rewritten. We are in now a phase of trying to figure out when and how the first Americans arrived. If they were here potentially 1,000 years before the ice-free corridor was open, how did they get here and when did they get here? So John Erlandson, my advisor at University of Oregon with a number of colleagues in 2007, suggested that they may, and he had been writing about this and others had suggested before, but they put out this hypothesis called the Kelp Highway hypothesis, that it may be, and it was sort of an ecological paper that demonstrated that there are many of the same resources that ring the North Pacific Rim that connect Japan, the North Pacific, down into North America in the same species of kelp forests, of kelp that are available, a break in the tropics where you get productive mangrove environments, and those kelp resources pick right back up into South America as a highway potentially down to Monte Verde. And so if you think about walking from Alaska to Chile, the mountains, the deserts, the different adaptations different challenges that would face you, the coast potentially offers a migration route with sort of the same kinds of adaptations that could be applied throughout, right? So by that, we mean the same kinds of shellfish and fish and sea mammals and habitats available along this Pacific Rim that may have actually facilitated migration into the New World. And even at Monte Verde, as part of this spectacular preservation, there were produced 8 different types of kelp and seaweed. So these folks were engaging in terrestrial hunting and gathering and going after coastal resources, again, 1,000 years before Clovis. And so to explain, well, the big challenge is, right, that we have this ecological model. We've missed all these early sites for decades, right? I just told you about Clovis first for 6 decades. How could we have missed this? Why have we not been working on the coast? Well, one of the problems is, well, where are all those sites on the coast? Right? They're under, you already know, you already have the punchline, right? So I always tell my students that the most difficult questions in life can be explained with squiggly lines. This is one of them. Right, and this is a record of temperature through time, cold and warm, and this corridor of migration was at a time when sea levels were much lower. 5% of the world's water was captured in high altitude and glacial ice that made sea levels dramatically lower. And if these people were following coastlines into the New World, those sites may now be underwater. And this is where I live, so I show this just as an example. So I live in San Francisco here. And so from downtown San Francisco, from Golden Gate Park right there where the California Academy of Sciences is, 14,000 years ago, you could walk out to the Farallon Islands, right? So dramatic coastal change, up to 120 meters over the past 20,000 years. So significant change that may have sort of submerged many of these early sites of this coastal migration. So unfortunately, whoa, we can't just say they're underwater. Yeah, rapid. We can't say these sites are underwater. I've tried that with my colleagues. They're underwater. Trust me, they're there. We have to go out and find those sites, right? Or still test this hypothesis. And then that's sort of the phase we're in. And the Northern Channel Islands turns out to be one place that is just absolutely spectacular for looking at this kind of question. So we have, of course, the Northern Channel Islands that you're all familiar with. And these are very dynamic islands. 20,000 years ago, these islands were connected to one another where you can walk from Anacapa to San Miguel. But you couldn't walk from the mainland, of course, out to the islands, right? So these in the Quaternary, these have not been attached to the mainland. The islands haven't been attached to the mainland. But 75% of the Channel Islands that we know today have been submerged by this last glacial maximum sea level rise, right? So a significant landscape is now underwater. So despite that challenge, we have one of the most significant clusters of early sites of anywhere in the New World. It's absolutely spectacular, the oldest of which has been found at Arlington Springs, excavated by Phil Orr at the Santa Barbara Museum of Natural History in 1959, and recently dated by John Johnson to 13,000 years ago. Right, so on the order of Clovis, and certainly not Clovis, on a very different adaptation where people had to be in boats to get to these islands 13,000 years ago. After that, sort of some of the oldest sites until recently has been a very famous site. This is Daisy Cave that has a variety of deposits that span the Holocene, but the oldest of which are about 11,600 years ago. And while Arlington Springs is a set of human remains and no archaeology other than those human remains. Daisy Cave has a spectacular set, has produced this spectacular set of archaeology, including chipstone technologies, things we call crescents, and I'll get to these in a minute. Sandal fragments, these woven seagrass sandals. Olivella, purple olive snail beads, where they've just ground the top off. These are probably trimmings from fishnet construction or some such, these sort of knots. And these are the oldest bone fish hooks in the New World, bone bipoints, fish gorges that were used for fishing. And a colleague at the Smithsonian, Torben Rick, did a lot of work on demonstrating an adaptation of not only shellfish gathering, but intensive kelp forest fishing 11,000 years ago. And not much other technology. This was found at the bottom, and I'll show you why this is important in the next slide, but this was found by Charles Rozier, who was one of the first to excavate Daisy Cave. He found this at the bottom of the cave, and when John Erlandson excavated Daisy Cave in the 80s, he thought that this point, it looks like a bow and arrow point. It's really small, really delicate. We know bow and arrows don't show up until about 1500, after 1500 years ago, so they're very recent. And so we thought this was found at the bottom of the cave and the bottom of Rozier's deposits. And we thought that it was just intrusive. A variety of processes, like ancient construction of burials to deposit individuals. It could have moved down during excavations, a variety of ways we can explain this, but we just thought it was intrusive to these bottom of these deposits. And that all changed in 2008 when Mike Glassow at UC Santa Barbara found a channel island. These are called Channel Island barb points. Here's that point from Daisy Cave. In a site on western Santa Cruz Island that dated to 8,000 years ago. So again, sort of a moment in archaeology where sort of everything changed for us on the Channel Islands, and we recognize that these Channel Island, these stemmed points, were diagnostic of very early occupations on the islands dating to at least 8,000 years ago. And from then, we began survey efforts looking for these kinds of technologies. They've shown up all over the islands. One of the largest has been on eastern San Miguel Island that has produced dozens of Channel Island barb points, these crescents. These are Channel Island barb points. These are a variety that we call them mole points, but very similar. Again, all dated to very early, these to 12,000 to 11,000 years old, right? But hundreds of these bifaces, no sea mammal, bird, fish bones, only shellfish, right? So they certainly weren't using these to go after shellfish, right? For any of you who've gone foraging for a mussel dinner, right? So what were they being used for? Well, John and I and Torben Rick and some other folks were sitting on eastern San Miguel here, and we're having lunch at this site, and John looked across and he was like, you know, you could walk 11, 12,000 years ago to Santa Rosa Island, to what is Santa Rosa Island today, right? It was dry land, it was all connected, didn't start to separate until about 9,500 years ago. You could walk across, and right across you could see where Arlington Springs was, right? And so the next season, John, Tori, Courtney Hoffman, some of their students, Leslie Reeder Myers, started a survey moving from Arlington Canyon, where Arlington Springs was found, that 13,000-year-old site, and started surveying the terraces along this and came up with 2 other sites that produced abundant stemmed points, early stem points, crescents, and sites that produced a new array of bone that tells us about what these were used for. So the remains of snow goose and Canadian goose, an extinct flightless duck, Chendiotes, and sort of and fish bone, sea mammal bone as well, to sort of round out that these were maritime hunting technologies. Here's another shot of some of those technologies. This is what archaeologists get really excited about, these really cool pictures of these really early technologies. Again, crescents, Channel Island barbs, and these are mole points. Probably hafted like this to hunt things like waterfowl, maybe as fishing points, hunt small sea mammals like otters, hafted on shafts and used perhaps with atlatl technology to do this maritime hunting. So that brings us where we are today. And then recently, two years ago, in April 2017, we found perhaps what is one of the largest very early sites on the island. This is sort of an accidental discovery, and it happened during construction monitoring on Santa Rosa Island. Work was being done to restore and is ongoing to restore the ranch house and create an interpretive area that's going to be spectacular. And we stumbled on a site that started to produce some of this early technology. And this has been, I've been involved in this project, and a lot of other people have. I mean, we've had Chumash consultants, the San Ynez, a variety of other Chumash communities engaged in this work. John Erlinson, pictured here, and Christina Gill at the University of Oregon, Gary Brown with MPS, Laura Kern here that did our introduction, interns and volunteers. And then I worked on some of the excavations, data recovery, but this became a huge effort to sort of understand this large site as this construction and restoration of this ranch house complex was going on. And it turned out to be a really spectacular sort of interaction with a variety of different with the Chumash, with archaeologists, with academics, with NPS, to sort of better understand the site and salvage as much information as we can in this, what turned out to be a really large site. So the main site area was right under this ranch house. And then we had another locus north of the ranch house. And just to give you an idea, I mean, most of the time when we're on the islands, what we're doing is we're digging in places that are eroding into the ocean. We're saving information before it's lost. Here we're excavating in a larger region to sort of gather information as this interpretive area is being put together. And we dug a variety of different units. We conducted paleobot analysis, augers and mapping of this site with a variety of different groups to bring this all together. And from it, it produced over 7,000 lithic artifacts, crescents, here a variety of broken crescents. These are Channel Island barb points, and a spectacular archaeology of paleocoastal early Holocene archaeology. And here's kind of the work conditions that this is from Gary Brown's work that we were working under this house to sort of salvage this site. Here's the different stratigraphy, and why I'm showing this is we did a variety of dating, and Gary did a variety of dating at this site and found that the dating was kind of all over the map. We had a lot of disturbance from this historic activity. The dates ranged from 19,000 years ago to basically recent, except a shell feature in part of the site that dated to about 8,000 years ago, right in line with those stemmed points, right, that I showed you earlier. However, this north locus, where we north of the ranch house, where we spent some time excavating small units, we found that all of these, this area dated really tightly between 11,700 years ago and 11,200 years ago. Again, a very early site, very large early site on the Channel Islands. So at this point now, after this site under the ranch house and around the ranch house, all the other sites that we found on the islands, we have something on the order. I think the real number is like 98. So I said 90. I'm a little low there, but we have 98 archaeological sites that date to more than 8,000 years on these small islands, 75% of which are now underwater, right? Absolutely spectacular. So just to give you an idea, here they are now. I don't have all the sites up there, but here's what those islands would have looked like 10,500 years ago. These are maritime hunter and gatherers using these technologies to go after fish and seabirds. Many of their sites may actually be underwater. And this has led to, again, another partnership that I've been really lucky to be involved with, funded by the Bureau of Ocean Energy Management, with the Park Service, a variety of academic institutions that I've listed here. There are probably others. There are others, all collaborating to start to look underwater. If we have this spectacular record, none of which is older than Clovis, might there be even earlier sites now underwater? Right? So to do that is probably the worst needle in the haystack exercise that you can think of, right? When you begin, but you could start to narrow targets. So we use the terrestrial archaeology, where places that people like to set up camps on subaerial archaeology today, or subaerial landscapes today, and we predict where these places might be underwater. So we have begun with developing this predictive model of high probability landforms where people might have gone to set up camp. And not only that, where those potential archaeology sites might still be preserved, right? Because some places can be scoured out by heavy wave action. So it's not only where they might be, but where they might last, right, for over 10,000 years. One of these places, so the Ranch House facility right in here, this cluster of early sites, 997 is one of those. There's a variety of others. These early sites sort of rim Santa Rosa and Santa Cruz. So these stars are all archaeological sites. Right in the middle of between Santa Rosa and Santa Cruz is this massive subwater submarine canyon that comes up right in between these islands, and 5 of the largest drainages on the islands would have drained into this bay today. John Erlandson called it Crescent Bay because we found these sites with crescents and stemmed points, and this may have been this really productive estuarine environment with these waterfowl, with sea mammals, with fish, with the shellfish that people were going after, that we see in the subaerial archaeological record. So after we predict that and find interesting places, we've gone out and used sonar technology to map the seafloor, but not only map the seafloor, map the subsea floor and look at the stratigraphy of the seafloor by using what's called this CHIRP system, launch it from a boat, and do this sonar mapping. And so I'll give you some example of what this produces, right? We look in Crescent Bay, this high probability area that we're really interested in. Here's one of our track lines, right on the edge of Crescent Bay. That's what you get. Very exciting. Everybody's quiet. It's time to go, right? Well, you work with marine geologists, and actually it is pretty interesting because what it shows is what we would predict. There's this Paleo Channel where fresh water would have made its way down to Crescent Bay. And on the levees of that Paleo Channel, there are what we're calling high amplitude reflectors, which means these kinds of signatures have produced archaeological shell middens in other regions in North America and the Gulf of Mexico. They may or may not be, but they're interesting features in the places where we think we should find archaeological sites, right? So what we thought should be there was actually there. So here's another one. Understanding these paleo landscapes, we probably know more about the surface of the moon than we know about the seafloor. And right along in Crescent Bay, here's the Santa Cruz Canyon, that big submarine canyon. Here are these what seem to be estuarine deposits, paleosols still preserved, right? That can yield a lot of information about what this environment looked like at the time. This is just sand transparent Holocene sediment sand that's piled on top of this, right? And so the final phase of our research has been to actually then, if we've predicted these places, we've sonar mapped these places, then to go core and look at these places, test these locations. So along the Channel Islands in these 4 places that we became really interested, 3 right in between Santa Rosa and Santa Cruz, we recovered 26 seafloor cores, ranging in depths from about 75 to 25 meters. The longest core is about 2.5 meters long. We tried to find places where there's not a lot of sand buildup, Holocene sand built up, where we can maybe try to find paleosols. So at this point, all of these cores are up at Oregon State University. I wish I could tell you what we found, but they are still cores up in a core facility being scanned and logged. And unfortunately, next month I'm going up there. Well, fortunately for me, unfortunately for you, next month I'm going up there. But we hope to find these estuarine soils and kind of features that we predicted. This is the first step, right, into finding archaeological sites. Just to be clear, I would not put any money on us actually finding an archaeological site. That is a losing bet. Bet on the Warriors instead of that. But this is the first step, understanding these submerged landforms, being able to predict them, being able to accurately predict where these are preserved, will down the road help us identify, I think, submerged archaeological sites that can help us unravel this question of the first Americans. So where does that bring us? Things are really interesting. I have no answer for you. Clovis is not first. Clovis is real. The story you heard is wrong when you were in school. We don't know when and how the first people arrived, but we're walking down that road to figure out that answer. And the Channel Islands are going to be key in helping us figure this out. This one of the many reasons the Channel Islands are so special is this density of early sites on the island that can tell us what people were doing on those islands, that can help us predict where those sites might be underwater and help answer this question. And it's going to be methodological advancements, new analytical techniques like this sonar mapping, like this offshore coring, and it's going to be interdisciplinary work between agencies, between academics, between interested folks that are going to contribute to this work. So stay tuned. Hopefully we'll have an answer at some point. And I wanted to say thanks. You know, I was invited here to kind of talk a little bit about this excavation at the ranch house, and I did a little bit, and I tried to frame it in a larger context. But I wanted to say this crew, and they're not all here, was key in helping us complete this work at the ranch house and at 997, and this really important early site on the Channel Islands. And a variety of folks really worked hard to make that happen, and I really appreciate it. So, and a variety of collaborators on all the work we do. So thanks so much. I can answer any questions. I saw a hand up first, right over here. Yes. Mm-hmm. Mm-hmm. Right. Yeah. Yeah. I would first tell them that the archaeology is a treasure that is our shared human history, and seeing it and leaving it alone is probably the best thing we can do. But what really excites me about the archaeology out there, and what I tell my students and tell folks when I'm out on the island, is that, you know, we know what the islands look like today, and we have a lot of great folks who work really hard to manage the islands and make them the spectacular place they are. But we know the islands have undergone tremendous change, right? Especially in the last 50 to 100 years, where fishing has changed the marine ecosystem. Ranching, which is an emblematic part of the islands, but it changed the islands in a lot of ways, right? And they've undergone tremendous change in the plant communities, the animal communities, both marine and terrestrial. And archaeology is actually one of the absolute keys to figuring out what these islands look like for thousands of years, right? And if we're going to really restore the islands and figure out where these islands are headed, we have to know what they look like in the past. I'm not saying we have to put them back to what they were. That's probably impossible, right? There were domesticated dogs out on the islands for thousands of years. There were thousands of people out on those islands for thousands of years, right? So we're not going to put them back to what they were, but it gives us a roadmap to what's possible and what we want them to look like. And it's, for me, and I'm an archaeologist, so I'm biased, archaeology is some of the best records to do that. So if we lose those records, either eroding into the ocean or we don't take care of them, then that information is lost and we are steering the ship blind. Yes?
Someone told me that there was a cave in Whitfield Canyon just downstream from the
There are lots of caves all over the islands. Yeah, I can't really comment on particular caves and what they are and where they're at. I would just say there's caves all over the islands. Some have archaeological sites and some don't. Yeah.
The gaming you did at the ranch house, was that precipitated by them starting the construction project there?
So
And then you went there, or
Yeah.
did you start that prior to the
Yeah.
reconstruction?
So what happens when there's construction, or do you want to take this?
No.
Oh, I'm sorry. Okay, yeah, that's great. So the question was the work at the ranch house precipitated by construction, or did we start first? NPS started first, right? So archaeologists go and they look for sites, and the islands are archaeological sites. So this is very, very difficult, right? Yeah, so they look for archaeological sites, they assess and they do consultation. Then if everything seems to be a go, they start construction, and that's what happened. Construction and renovation was started. An archaeological site popped up because subsurface work had to be done, which often happens, right? Because you can't, if it's not on the surface, you don't know it's there potentially, right? So, and there are other ways we deal with that, but you don't always know. Things came up, everything was halted, a new plan was put in place. Gary Brown came out, did a bunch of work first, and then once that was done and we knew more, then I came out and did even more work. And then once that was done and everyone felt comfortable with, we have all the information we need, we've properly salvaged, we've put a good plan in place, then restoration work began again. Yeah.
When did that word locus?
A locus is so we can have, we consider, we put boundaries around sites, right? And within sites, and those can have multiple different, just so think of your house as an archaeological site. You have the backyard where you may barbecue, that's one locus. You have the place where you live, that's another locus. You have the garage where you park your car, that's another locus. Similar kind of thing with archaeology. There's different activity areas. They may date to different things, and yeah. Yes?
Can you talk a little about the Kelp Highway?
Sure.
That whole corridor?
Yeah, so
Down from Meridian, all the way down, how wide it was, and what kind of archaeological finds have been
Yeah.
all the way along the way?
Sure. So the question was a little bit more about the Kelp Highway, what that means, what the archaeological signature along that potential route may be, and what that looked like. So the Kelp Highway is largely an ecological model that just shows that there are these similar kinds of habitats that sort of circle the North Pacific Rim that may have facilitated migration. In places in the old world, like in Japan, we have sites that date to 16,000 or more years ago. A very early archaeological record along coastal locations along that route. We have maritime voyages out to the Ryukyu Islands like 25,000 years ago, right? So we know that people were sort of adapted to these maritime environments very early in that part of the world. As we move into, Beringia area, there is just a massive area that was once above water that is now submerged. In that place where there's in Beringia, you can go miles and miles and miles offshore and still be in places that during the last glacial maximum would have been above water, right? So there's very little archaeological record, early archaeological record in the North Pacific, right? So you get to places like Washington State. There are sites that now date to 12,000 years ago, 13,000 years ago. You have Monte Verde down in Chile at 14.5. There are sites in South America that date to about 15,000 years ago that are on the potential coast, but there is very little archaeological record that's older than Clovis, older than 13,500 years ago on the modern coastline. And I think many scholars think that's because those sites are potentially underwater and we need to find them. Yes?
Would you say that it's helpful to have input from anthropologists and academics who have looked at much older sites?
Yeah.
And I know one in particular advocated underwater on our coast. He says most of the best sites are most likely underwater.
Yeah, so absolutely, and more of that has happened. Honestly, the logistics of that have been challenging for academics, and we're trying to do a better job of interacting with different scholars around the world, and that stuff is happening. I've been to workshops about migrations in different parts of the world, and folks, maritime migrations in early maritime migrations in different parts of the world. So scholars are getting together and sharing knowledge and trying to confront these problems as sort of a global community. But it's probably in its early stages, and more of that work needs to be done. So absolutely, yeah.
If I may go on one other thought here, that is climate change, sea level rise. Aren't you guys running this?
Absolutely, 100%. Yeah. So, sea level rise and anthropogenic climate change is we are talking about that across agencies, across universities as a major problem for the preservation and protection of coastal sites around the world, and it is a daunting task, right? Because coastal sites are going to erode. They're going to erode. That's part of the process. There is no stopping it, but the rate of erosion with anthropogenic climate change is accelerating, and it's a challenge we need to confront. Yeah. Yes.
I was wondering what kind of you figured out what kind of processes you will use to look at sites underwater.
Yeah, processes we'll use to look at sites underwater. Right now, it's coring, but there are other ways. So in those cores, they're 4.5-inch diameter cores. So even if we were to hit an archaeological site or what might be an archaeological site, we would have to go back and do more work because it would be really difficult to really nail that down as really being an archaeological site. And certainly we'd want to learn more. So it just depends on the depths of things, right? So ROVs, autonomous vehicles can go down and do sophisticated work. We send divers down. Our park archaeologist is a diver that is going to help us out on a future project. And so there are a variety of different ways that we can do that, but it's time and effort, and there's a safety element that all plays into it that makes it a really challenging environment. Yes.
The focus seems to be on the northern Channel Islands.
Yes.
Are the southern islands devoid of archaeological sites?
No. Yeah, so that's a great question. The focus is on the northern islands because the southern don't have archaeology. There's spectacular archaeology on the southern Channel Islands, and there are a variety of colleagues who are working on that. I focus my time on the northern islands just because I've spent my career working here. But there are a lot of great efforts, including offshore efforts on the southern islands. So there's great archaeology. It's different archaeology. It's different in character and in nature. Those islands are much different, but there's a lot of similarities with the northern islands, and there's a lot of folks doing that work. I think there's been a longer history on the northern islands, perhaps because of it's a national park, and the facilitation of research by the national park for 30, 40 years now has really helped.
Are the southern islands comparable to the northern islands?
Nearly. There are like 9,000-year-old dates, 10,000-year-old dates on the southern islands. There's not nearly as many on the southern islands, and we could go down in the weeds on that. But part of it, I think, is sort of the distance from the mainland to some of those islands. And then you have Catalina, which is closer and a larger island, harder to survey, still a population out there, a lot of different sort of challenges. And so the protection of national park has kind of been instrumental in helping develop this record and understand this record. Yes?
You have in South America, Chile, and Monte Verde going from age wise from the southern part up to the northern part.
Right.
What the browser is talking about. We have in North America going in different directions.
Yeah.
Why is there nothing in Central America?
Yeah.
Or there is nothing?
I have not personally looked there. Folks have looked there. I would love to go look there. Yeah, oh, great. So the question is, there's a really early site in Chile, in southern Chile, and there's early sites in North America, and it seems North America, you go north to south, but South America, you go south to north. Where's the muddle in the middle, right? What about Central America? It's the challenges of doing work in some of those places. Those mangrove environments are really difficult to work in. It's partly it's just the history of research. There hasn't been an intensive effort in some of those places in Central America, and there's been vast tracts of South America that have had that effort. And for me, when I look, I look at the record, the places where there's been concerted efforts by groups of archaeologists to find early coastal sites have been found. So there's Peru and Chile, coastal Peru and Chile, a lot of work has been done. And I didn't even show you all of them. There's a number of sites that have been found. Pacific Northwest, there's a lot of work that's been going on around Hawaii, and a number of early sites have been found. Channel Islands, same thing. So, but not every place is great for looking for sites. So if you look at a place like Northern California, far Northern California, Oregon and Washington coast, that place has the Cascadia subduction zone right offshore. It seems to slip about every 300 years, causing a massive tsunami to come hit the coast. And that would scour an early archaeological record. So some places, because of these geologic processes, aren't great places to look. And it's probably not because people weren't there. It's because the record hasn't preserved. Let me get someone. Yes.
So, I saw on that map with the data.
Yes.
And there were older dates and stuff, and
Yes.
so is it controversial at this point to think that the
Yeah, that's a great question. So the question is, well, we get these earlier sites in South America. How about people moving south to north along the coast, right? Just like I told you with Clovis, like, moving up the corridor, right? Is that controversial? And I would say, yeah, most people would not consider that the route. And that's not only because of the archaeology, there's linguistic evidence, there's genetic evidence that suggests that there's connections to Northeast Asia that make the most viable route a Pacific route moving from Northeast Asia into the Americas. And I don't think we don't have the earliest sites, right? So all of that's going to change. I hope in 20 years, Monte Verde is just another early site on the coast, and it's no longer the earliest or not even close. I think that's the direction hopefully we're headed. So I think the story is going to fundamentally change. Yes.
How long do you think, either in generations or in absolute time, would it take for the Kelp Highway to travel from Alaska to Chile?
Yeah. Yeah, so that's a great question. So how long does it take in generations or whatnot to travel from Alaska to Chile along this Kelp Highway? And, I don't have a good answer for that. Just answer anyway. Even give a bad answer? I'll give a bad answer. Well, I'll hedge on my answer. How's that? So when this Clovis first model was in place, there were there was a group of archaeologists that were doing sort of mathematical modeling of how quickly, right? Because the whole continent basically and all of the New World gets populated in 600 years. And you're like, that's really fast, right? 2 continents in 600 years. How can that be? And actually, with mathematical modeling and birth rates being fairly moderate, and highly mobile people moving across the landscape, these mathematical models suggested that it was possible, right? So I think this idea, I always sort of, when I'm thinking about archaeological questions, I always try to be careful about how long it would take me to canoe from Alaska down to Chile is not a good measure on how long it would take people that were well adapted to these environments and lived them all their lives and had their parents and grandparents and great-grandparents teaching them how to do this. It would be very different. So I think it could be actually very rapid and a very rapid migration. Why they might do that, why they might make that migration is also, I think, a really interesting question, and another I don't have a good answer for. But this idea of exploration and seeing what's along in the next harbor and the next cove or resources that might be available, people can move pretty quickly. And in fact, we know that Polynesian peoples, very different adaptation, very different technology, but they spread around the vast Pacific very, very quickly. In a matter of, 3,000 years, they had colonized the entire Pacific and every little speck of island you can find. Again, very different technology, but gives us this lens into how quickly people can move when motivated.
Any evidence on primitive watercraft that we use?
Yeah.
We're talking mostly a
Yeah.
terrestrial.
Yeah. So that. Yeah. So what about watercraft? Yeah. When we talk about, so what kind of watercraft might this migration look like? Again, we have no idea. Yeah, I would suspect things like skin boats, but those don't preserve well in the archaeological record. And we're talking about a migration within kelp forests, right? People aren't going, we don't envision this kind of migration as people going out into the deep ocean, right? They're not going pelagic fishing. There's no evidence of that, but it's in kelp forests where wave action is sort of a little calmer. You can have hold fast for boats, but what kind of boats those were, we don't really know, right? We don't know much about those early boating technologies. It just doesn't preserve, right? I mean, reed boats were probably the early boats on the Channel Islands, but if those technologies change, what those look like, if if there were different kinds of boating technologies coming from Northeast Asia, we don't really know. One more, yes.
Yeah, I heard there were studies that you could create an analysis of data population with migration routes. How does that correlate to
So we work. So there's a lot of great work going on in the genetic world, doing ancient DNA work, looking at ancestry, and that field is changing at a rate that I can't even keep up with. Like every week, it seems like a new significant genetic study is coming out about early migrations and peopling of the New World, and it's spectacular. What I would say is that is also a changing landscape, partly because the methodologies and the technologies are changing so rapidly that we're getting more and more information. We're able to sequence more and more genetic material to put towards this question, but it still remains a field that is like archaeology. We have a small number of these early sites. They have a small set of data that they're using in terms of like sample size, right? They're getting more data from this small sample, but they are building these sample size, and the jury is out on where that is headed. Right now, it meshes well with the archaeology that it connects with a coastal migration along the Pacific coast from Northeast Asia sometime since the last glacial maximum, between probably 18 to 15,000 years ago. But again, that can change.
Can you hear me? There we go. That was really fascinating. And as long as I have you guys as a captive audience, I know many of you are with the Naturalist Corps. And those of you who aren't probably love the islands and visit and talk about them. So thank you for your service. There was a question about what do we tell people who might encounter archaeology? And I wanted to just share the Park Service perspective. Todd talked about just really eloquently about how these are touchstones to the past and really one of the most important keys, scientific keys to unlocking these complex puzzles. It's also important to tell visitors that if they encounter something like this, not only is it, the right thing to do to appreciate it in place and leave it alone, it's also important to know that these landscapes are treasured by our tribal partners, the Chumash people, and to them, these are the places of their ancestors, and it's their ancestral homelands. And they are very, I would say, very concerned that we protect these places. And if all else fails, it's against federal law to pick up or damage or destroy any archaeological resources on federal land. So we have many layers of protection, many, many, many good reasons for leaving these things in place. So we really appreciate you spreading that word. And thank you so much for coming out tonight. This was a fabulous conversation with Todd. We really appreciate you sharing your information. And I hope everyone is as inspired as me to envision these places as they once were and will be. Thank you.